Chapter 2, Section 6 is about Newton's third law, also known as the law of action-reaction. Taking a look at this picture, what do you see? What evidence of forces can you observe from the picture? Take a moment and jot down your observations in your binder. Looking at the picture, we see evidence of forces in many places. We have the person pushing on the wall. We have the person on the skateboard. Those are just a couple of examples. But when the person pushes on the wall, how is it possible that the person ends up going the other direction? Based on Newton's first law, we know that in order to get something to accelerate, meaning changing its motion, there needs to be an unbalanced force. Well, you cannot put an unbalanced force on yourself, so there must be something pushing the person in that direction. But what is it that's pushing the person in that direction? What causes that unbalanced force? That's really what action-reaction is all about. So the idea is that you're pushing and pulling back. So when you're walking, that's an example. How is it possible that people can walk? What makes things move? Well, when a person walks, they're pushing back on the ground. But what's the ground doing? We know the only way to get something to move is to have an unbalanced force. So there must be some kind of force acting in the opposite direction to push you forward as you're moving. And that's true of any object. In order for an object to move, there has to be something pushing or pulling them to make them move. In the investigation, you did this when you were pushing against the wall while you were sitting in a wheelchair or on a skateboard. You gave a force to the wall, and you ended up accelerating. So when you were pushing on the wall was pushing you back. So in order to make anything move, an object must be pushed or pulled by some other object. There has to be some kind of force involved. This is what Newton's third law says about motion and forces. For every applied force, there's an equal and opposite force. And most importantly, these two forces always act on different objects. So we have two objects that are affecting each other. And you see some examples from the investigation listed here. Take a moment to read through them. Pause the video while you read. If you have not done the investigation yet, make sure you go back and investigate this for yourself, so that you have a real understanding of what this feels like. Another way to test Newton's third law is to have two people pulling opposite directions on the spring scales. You can find the spring scales in drawer number 2 in the orange cart. When you pull in opposite directions, you pull with equal force. There is no way that one person can pull with more force than the other person. Go ahead and try it and see what your results are. Another example of Newton's third law is, this is also from the investigation. In here, a meter stick pushes up on an object with a force equal to the weight of the object pushing down. And in the investigation, you can see this very clearly because the meter stick will bend with the force of the weight of the object. So make sure you do the investigation to see this for yourself. This happens with all objects. When you're standing on the floor, you're pushing down on the floor. Your weight is pushing down. The floor is holding you up. The floor doesn't bend like the meter stick does, so it's hard to tell, but that is exactly what happens. When you're pushing down on the floor is pushing up on you. So how do we keep track of forces acting on objects? We do that with something called a free body diagram. So whenever you're showing the forces acting on an object, you draw something called this free body diagram, And in the free body diagram, the object is always represented by a square or a circle. It makes drawing them much easier. So any object you have, whether it's a car or a person or the tiniest object like a little mouse, you just shrink it down to a circle or a square. And then you start showing arrows for the direction and the amount of force. So let's say we have gravity pulling an object down, which there always is on Earth. And then we have a floor that is pushing an object up. So let's say that this is a chair sitting on a floor. Gravity is pulling down, the floor is pushing up, those forces are equal and balanced, and therefore this chair is standing still. What if somebody comes in and starts pushing on the chair and moving it across the floor? In this case, the forces would be unbalanced and the object would accelerate. Let's say we add some friction. And now we have the forces balanced side to side. Now the object would be moving at a constant velocity. And so what we do is we label those forces so that we can keep track of which forces are acting on the object. Here's our completed force diagram with the labels. You can see the support force is from the floor, and we see that here labeled. And then we have the applied force from the person. We have the force of gravity, and we have the frictional force. Free body diagrams represent each force acting on an object. The amount is the length of the arrow, and the direction is the direction that the arrow points. You want to make sure you don't get Newton's third law confused with Newton's second law and first law. Some people ask, if the forces are equal and opposite, then aren't they balanced? How could an object move? So one thing to remember is when we're talking about Newton's third law, we're talking about pairs of forces that are equal in amount and opposite of direction, but acting between two objects. So here we have the force of the person on a chair pulling this way, and we have the force of the chair on the person pulling this way. Two different objects. Those are equal. And here we have the force of the person on the ground, and we have the force of the ground on the person. Those two are equal. But if we look at the information that we're given here, we can see that the forces of the ground on the person, or the ground on the person, and the force of the chair on the person are not the same amount. So the forces acting on the person, if we look at the person as our object, those two forces are unbalanced. And so if we do a quick force diagram, we've got gravity pulling the person down, and we have the floor pushing the person up, but now we have this force of the chair this direction, and we have the force of the ground this direction. These two forces are balanced, but these two forces are not. And that's why a person accelerates forward, because they're actually being pushed forward with a greater force than the chair is holding them back. And that's the difference between Newton's first law and Newton's third law. And it's really important to not get those two things confused. If you have questions about these things, make sure you're asking. To check for understanding of Newton's third law, in your binders, please identify all of the action-reaction forces that you see in the picture. So the action-reaction force pairs. Object A interacting with Object B interacting with Object A. Make a list of those in your binder based on this picture. If you have questions, make sure you're checking in. Thanks! Have a great day!